I have a pleasure to introduce our next speaker, who is Piotr Osiewicz. Piotr is a software developer from Krakow with a huge affection to high-performance technologies. He's also a performance enthusiast, and this trait especially sparked his interest in build performance. While Piotr had no opportunity to work with large code bases yet, because those large code bases will take hours to build, he believes he has two cents to share. And I strongly believe he does. When asked about himself, Piotr shared that he loves taking photos at most unexpected moments of a day. So be aware and watch out for him during the lunch break. And he also overuses his headphones, but he has only the mic, so he's prepared. In his presentation, No More Coffee Breaks, Reducing C++ Project Compilation Time, he will show us the ways to reduce build times. So I think that all of you are here hoping to hear it, but also explore the potential trade-offs that must be made in order to use them. And I must admit, Piotr is very serious about his saying no more to no more coffee breaks, because he claims he doesn't have time for that, because the builds are just too quick and the tea must suffice. With this note, please, round of applause for Piotr Osiewicz.
Thank you. And I see that we have a lot of coffee addicts in the room, so that's good. So just to get started, who here has attended the Victor's talk this morning on stage 7, I think? Yeah, the first track. So he actually mentioned that if we could reduce the C++ builds by even a half, billions of dollars could be saved in this manner. And so the builds are kind of it's a relevant topic for good reasons. C++ is often thought of as the slow language to build, as in the programs written in it tend to take minutes, hours, hopefully not days, but well, it can happen, right? And so perhaps we can do better. And yeah, sure, we can. And first, a short intro, although Agata did a great job of introducing me. But yeah, I'm a C++ enthusiast, also a freak, but yeah, regrets, mistakes were made. And I'm also a software engineer at a security-related company, and I live in Krakow, and I take can you see the background, by the way? I don't think you can, or it's the angle. Anyways, yeah, I just take photos, run, and do all of the kinky stuff. Oh, well, not kinky, sorry. So first, I would like to hold a short survey. How many people here have the code base that takes seconds to build? So we don't have to wait more than a minute. Well, then you might be in the wrong room then. But I'm also this person, so you're not alone. Minutes? Up to an hour? OK. Hours? Well, I feel sorry for you. Days? I hope not, but oh. OK. Let's talk after the, the presentation. So most people here, for the reference of people who watch at home, have the code bases that take minutes to build. And in my opinion, that's acceptable, although it can be troublesome at times. So that's where the aforementioned coffee breaks come from, because we have so much time at our hands that it's inevitable, right? OK, great. That's perfect. We went black. Not cool. Ogólnie to nie ma ekranu. These kinds of issues are the best ones when you least expect them to occur. Well, sorry for that. Nie idzie sygnał na ekran.
Before we have this unexpected technical issue, why not to do some small exercise? You have a partner on your right or left hand side. If you just turn to each other and talk a little bit, why does it take so much time, in your case, about the build system? I think that could be a long discussion, but we shall see how long will it last. But let's try it. You can also turn around if there's no one sitting next to you, but I see the meeting room is full, so definitely there's someone who has a ear for you and will definitely like to hear what's your problem. The good news, Piotr is not only performance enthusiast, but he's also so well prepared that he can do his presentation without the slides. So big applause for Piotr. And in the meantime, we will figure it out.
Yeah, although it could be a bit harder for you because I had some code samples. But for the first part, we don't really need the slides here. So my presentation is split up in two parts. The first one is sort of the introduction, and in this part, I basically wanted to explore, or well, get us on the equal footing, sort of. So basically, we will go through some basic terms for the which can be useful when we talk about building the C++ project, although it can also apply to C. And so C++ build process is split up in three parts, two of which take place for each source file that you pass to your build system, and the last one is the linking stage, which puts it all together. And I'm pretty sure we all know that. We've all heard these magic words over and over again during our careers. But perhaps we should actually understand what it means. So with preprocessing, we deal mostly with text, and we perform textual replacements for preprocessor tokens. And so we can, by the way, I also have these slides on my website. I forgot about that. So if you have your mobile phones, you could probably use it. Sorry for interrupting, but I've had a context switch, sort of. So just to continue, we have to replace some preprocessor directives, the most popular of which is the include statement, which basically replaces the line with the include directive with the contents of some file from our drive. And then, after we preprocess the file, there is what we get is basically a source file without any preprocessor directive, and that is a translation unit. Translation unit is an input to the compiler, which is then turned into some intermediate representation, which can be reasoned about and optimized. And the compiler's job is to also generate code for it. Although translation units, they can sort of refer to each other indirectly by the means of declarations, for instance. So when you want to call a function that's not defined in the same source file, what you do is probably to place the declaration for the function in a header file that is then included by the translation unit that contains the call. And so these dependencies, so calls to things defined in different translation units, are resolved at link time. And the linker's job is to, well, I've just said that. It's to resolve the dependencies, but it does so by using something called object files. Object file is an output of the compilation stage for each translation unit. So as an input, we get the translation unit, and as an output, there is an object file which contains machine code for the target architecture, and also information about symbols. And a symbol is, well, it's an entity that's either defined in the file, as in we can have, for instance, a variable global variable definition, or the function definition, non-inline function definition, that is. And there can be also the dependencies of the given object file. So, for instance, there is an unresolved call to some function foo that takes an int, for instance, and all of that is done at link time. So, with that out of the way, and that's where the slide might get a bit useful, might be useful. There are actually two kinds of symbols. Because if you think about it, I'm pretty sure we've all had to deal with a situation where, for instance, we had two definitions for the same function. And the result of, well, at link stage, it could be a linker error. And I say could be because it's not. It depends on the kind of a symbol. We can have either weak symbols, which are allowed to have duplicates across the whole program. So in different OBJ files, there can be multiple instances of the same symbol, or a strong symbol, of which there can be only one. And if we have several strong symbols in our program for the same entity, and one, did I say strong or weak ones? Strong. Okay, sorry. So I mean, when we have several weak symbols for the same entity and one strong symbol, the strong one will always be picked. On the other hand, we cannot have two strong symbols that resolve to the same name because that's an ODR violation. And yeah, we're not done yet, although this is a bit problematic, as we'll see, hopefully, on slides. But let's continue. So one last thing that I would like to cover in this. By the way, is everyone following along up to this point? Or okay, sure. I mean, great. Sorry. So two last caveats is the template instantiation. So there are actually two ways to instantiate a template, and there's an implicit instantiation and an explicit one. And in our programs, we tend to use the implicit instantiation because, well, it's convenient, and I'm pretty sure some of us, well, at least I didn't know that, that the implicit instantiation even exists. So the implicit instantiation of a template will give you a weak symbol for the in the translation unit. So for the first time you use the template with some given argument set, you'll get an implicit instantiation for the particular symbol. And that means that if you have several translation units that each use the same template, say vector of ints, for instance, vector of ints will be instantiated in each translation unit that uses it. On the other hand, there is also an explicit instantiation which produces a strong symbol. So that means that you cannot have two explicit instantiations for the same template with the same argument set. And yeah, and it can occur only once. I'd like to show the syntax for it, but yep, stuff happens. So that was the first part, and Does anyone have any question? Do you have any questions?
A mic? Yeah.
Okay, I have one question. How is the partial instantiation treated? As
You
a
mean
weak or a strong symbol?
You mean the specialization of a template?
Yeah, I meant the partial specialization of a template.
I assume it would not impact the symbol here, because that's the issue. The syntax for explicit instantiation is well, it's a bit different, but I'm not 100% sure, so I'll check it and I can give you an info. Although I assume it would not have the impact on the instantiation.
Okay, thank you.
No problem. So you can have I think you can have the template specialization in a header file, and if that's the case, then that would mean that it's a weak symbol. Yeah, so then it's fine, because if it doesn't instantiate anything, and why would it? Then it should be fine. Okay, so now we're kind of blocked with the second part, but in the second part, I'll basically refer to this short introduction by reusing the building blocks that we've just laid. So,
any other questions from the audience?
Yeah, we can make I would say instant or some surprising Q&A session maybe now, because we have the time, it allows us it. Maybe Piotr would like to talk why you just came up with the build performance in the first place, and let's do some maybe interview, or there are questions from the audience, so that will be also great to hear. Are there?
Please raise your hand if any.
Then maybe interview. Why not? We have even the chairs here. We can use them for some point.
I have a question for you.
Yep.
We're talking about build performance. What's your take on the upcoming modules?
Wait, where are you? Here. Okay. Modules. I have the slides for modules, and basically, I have no strong opinion because I don't have the experience with them. But based on what I've learned up to this point, there are some concerns with modules based on the fact that there are interdependencies between the translation units, although there are also proposals to, for instance, allow for quick dependency scanning in the, well, at least in Clang. So it's hard to say right now. I mean, the fact that we can isolate the module interface unit at the preprocessor scope, it's very nice, although, yeah, the parallelism of the build can be a hit.
Mm-hmm. Who would like to ask Piotr something else as well? Except of this guy. Yeah, I saw some questions there. Maybe you can help us a bit and come closer? That will be great.
Yeah, that would
Thank you.
Welcome.
I saw two guys. One is only running.
Yeah,
Okay.
I'm from the group of at least 3-4 hours of build time, and our project. Do you maybe, from your experience, know if excess of includes at the top of the files can attribute to prolong that
Yes.
compile time?
Yes, it can. Personally, wow. In the code bases that I've worked with, the excess of the inclusions in the of included header files. Wait, who's making this noise? Okay, I hope it's not me. If it is, I'm sorry. the header pre-compilation, which is what I'm going to talk, I hope I will have the chance to talk about in my talk. Oh man. Attributed to over 60% build time reduction in my case. Although, when we talk about them, it's very hard to reason about them without having the chance to inspect the architecture.
So, in order to alleviate that issue, is it? Would you think it would be preferable to have, let's say, a rule that only the base files are included and that there are no avoiding cross dependencies is the first step.
Yes.
And not having, including the file that has a lot of includes deeper
Yes.
down and needing only the bottom one.
Yes. The specification of the include can help as well, and you probably shouldn't rely on the transitivity of an inclusion anyways. That's my point of view. Windows.h is a good example of a very big header. That also includes other headers in the process. So as I've mentioned, the header precompilation is probably the first. It's a good starting point in my opinion if you don't do it already. Can I ask you what compiler vendor are you using?
GCC.
GCC. Okay. Well, from in Clang there is an F-time report, or it could be the other switch, but basically in Clang 9 they've added something. What's this? Great. But it's not on my laptop though, so it's a bit problematic.
Where is it?
Perhaps I could.
Okay, so that might be very helpful.
Yes, sorry, so I'll just finish because I have this tendency to context switch a lot. So with Clang, you could have the, I think it's called a flame chart or something like that, which shows you which things were the most expensive to instantiate. And basically, it would lay out the whole build process for you in a way. So you could then, you seem to already know that your issue is the header inclusion. So yeah, it's, as I've said, it's hard to tell, on the stage without really seeing the source code, but in general, precompiled headers, maybe single translation unit.
Okay, so with Clang, I could check how big of an issue it is, and
yes,
then
I mean GCC also has this option, as I think, but it's not in the form of a graph, so it could be a bit harder to go through. But I think it's also possible.
Okay, thank you very much.
No problem.
Thank you.
Yeah. The good news is that we will be able to make the presentation from the online source. Just we need to figure it out how to keep you here and get them with the online. But Szymon is on their way, and we will figure it out. So maybe in the meantime, one more question. I saw some people also running there.
By the way, the issues with the audio stopped when you turned off your mic, so. Perhaps I'm the last person to notice it, so. Great. So, no more questions? Really? Jasne.
1, 2, 3. Good news is I'm still audible with another mic. And I think just seconds will take us to make the presentation online. So thank you very much also for your patience. And you could help us even a little bit with one question to Piotr. One more. Anyone who would like to give more? Let's make an auction. Okay, I see someone. Yeah, are you for the question? Yeah, good.
Right.
Maybe not strictly related, but I'm building all OS system, and I'm not sure about dependency between components. Is there any way to optimize this process to not build everything from scratch, or I don't know dependency. You know, some application are dependent from OpenSSL.
Yes.
One developer changed flags of OpenSSL,
Yes.
so it requires rebuilding all OS.
So perhaps you could. So if I understand your question correctly, you want to know whether it's possible to isolate the components, so there is no need to do a full rebuild when only a small part of your dependencies change.
Yes, I don't know dependency. It's my big problem because
Yes. So I did not intend to talk about it in this talk, but there's actually something related in C++. So I'll give you an example here, and it will just apply to it. In my opinion, it applies to your case as well. There is something called pimple, which is pointer to implementation. When you thank you. When you don't want to rely on some on implementation of some class, you just use the pointer to well. Okay, I'm kind of tangled myself in a pretty deep web, but basically, you want to have the an official interface to the user that contains just the pointer to the implementation, which is a second class, and then the rebuilds, or rather the changes to the implementation, would not change the will not affect the user directly, and in your case, I think it could somewhat apply, as in you could have some interface in between that would be the only dependent of the OpenSSL. But like that's my first thought, at least.
okay.
So then you will only depend on the interface, and if the interface won't change, then the yeah.
It may help. It may
Yeah.
help, but I have no force to change all packages.
Yeah, I mean, when you complain long enough, it will eventually be done, right? That's how we make a change in the world, by complaining. And there is still no. Okay.
Yeah.
So I don't have the the preview here, so I hope I won't have to turn to the to my slides much. But we basically went through all of it. So through the glossary, right? Through the translation unit, object files, and symbols. And so, as I said, there are two kinds of symbols. Just to recap, when we have two strong symbols, that's an error, that's an ODR violation. And when we have several weak symbols, then they're all assumed to be equivalent, and the majority, except for one, will be discarded. And in case we have a strong symbol and several weak symbols, then the strong symbol will be picked. And template instantiations. So back to the topic of implicit instantiations, although this one was already solved, thanks to the contribution from the audience. So implicit on the first line, we have an implicit instantiation of the array, std array with int and free. In the second case, we also need to instantiate, the compiler has to instantiate the template, because it cannot know the result of the size of operator beforehand. But in the third case, there will be no implicit instantiation. And I'm kind of short on time, so I won't play games with you. That's because we want to query a size of a pointer. So the compiler will, if it doesn't have to instantiate the template, then it won't do it, and just for the reference. And the syntax for the explicit instantiation is this. So basically, we specify the types of, we specify the template arguments, and then for the function template, we also need to give the full signature. Great. So I can finally move on to the templates, which are one of the problems with building C++ project, and this part is of course C++ specific, but later on we will also talk about C a bit. So templates, since we mostly use implicit template instantiations, that means that your translation units will have to instantiate them over and over again. And if your templates are non-trivial, then that means that you're doing the same. The compiler has to do the same work over and over and over again. And that might not necessarily be what we want. Although, yeah, we will see in a second. So if you want to create a function, like a non-inline function that's callable from other translation units, what you do is place the declaration in a header file, place the definition in the implementation file, and then any calls to this definition, which is the single definition of the function, are resolved at link time. On the other hand, okay, sorry for having to switch, but I don't have the preview here. With templates, we tend to place the function template definition in the header file, which is then included by the by any translation unit that contains the call to the instantiation result, and then we get several weak symbols for the same entity across our program, which is then discarded at link time anyways. And perhaps we can do better. We could, in theory, remove the definition from the header file and move it to the implementation file, and then explicitly instantiate the template here with any argument sets that we think will be used in the program. So we place the function template declaration in a header file. Then we move the definition to the source file and instantiate it explicitly here with the argument sets. And the calls are will be resolved by the linker once again. And as a library maintainer, you're probably flipping the table because it's not sufficient way to. It's not a good way to optimize something that's for which you cannot foresee the argument set, because all of the argument sets that would be supported by your template have to be known beforehand. Additionally, if you think about it, the translation unit that would contain the explicit instantiation might plummet in dependencies, because if your argument sets are non-trivial, then that means that this particular translation unit might have to include some additional header files in order to perform the explicit instantiation. And in the worst case, you might end up with a slower build, even though your template instantiations would be reduced. The redundancy here would be reduced. Although, let's not complain, even though I've said that complaining is the only way to achieve something, it's good for internal development, as in when you are the person who's calling the code and it's not exported to the external world. It's convenient, but as I've said, if you need it to be a template, then it's pretty tough. So I like to call it the optimization of implementation, because you place the definition for the template in a single translation unit, which is, and in the same file you decide about the instantiations. On the other hand, if we limit the argument set, then what we are doing is generating overloads for the same function. So it's not really a template anymore. But since there is an optimization of implementation, there is also an optimization of usage, and that is external templates. So it is a feature introduced in C++ 11, and external template is a short way to call it. The full-blown name is explicit template instantiation declaration. So you can annotate the translation unit with an information that the explicit template instantiation for some particular template with given argument set is stored in different translation units. So it cannot be in the same one, but still the compiler will then avoid the implicit instantiations. So it's a good thing. because now we can store our definition in a header file once again and annotate each translation unit with external template, except for the one which would contain the explicit instantiation. And the only issue is that we don't, like, it's always hard for me to decide which translation unit should do the instantiation. And another survey, how many people here have played Portal? And you know what cake means? Yeah, it's a lie. It's not the only issue with both of these techniques. So since we were removing the definition from multiple translation units, the compiler will now be unable to inline the calls to the functions, to the instantiations of the template. So in worst case, we can get a worse runtime performance at the cost of build time. Although the cake is not really a lie in this story, because there is an LTO, which was also mentioned, or well, brought up by the Victor, that it can help with inlining cross-translation unit calls. So LTO stands for link time optimization, and in short, it allows for cross-translation unit inlining. So if you do use it, then you're good. I mean, there is these two methods will not result in worse runtime performance for you, or they shouldn't result in a worse runtime performance. And if you don't use LTO, well, perhaps you should give it a go, because it's not good only for the it's also relevant for non-template code, because, as I said, it's cross-translation unit translation unit inlining. Right, and that does it for the template part. But just to recap, actually, sorry, the external template is pretty nice, because if you forget to annotate some translation unit with an external template declaration, it will not result in a linker error, because since the definition for the template is available in header file, you will get an implicit template instantiation. Well, it's a bad thing from the perspective of the build time, but at least your build will not break. And as a library user, well, as a library maintainer, sorry, you don't really need to care about this part of build optimization, because now it's on the user of your library to optimize this, to extend the template, to put it short. Header files. That's another tricky thing, although it's also related to C++, to C, sorry. And the problem with header files is that, well, there are two problems, one of which might seem trivial. Since the dependencies are transitive, when we include a header file, we also include all of its dependencies, right? That's basic stuff. But we also have to reparse the same header files over and over again, because there is no cross-translation unit caching. At the scope of compilation, the compiler has no idea of the header file. So that means that your header files cannot really be cached in a simple way, except for some compiler extensions that we'll see in a second. So just a quick example, we have two source files and one header file. So the rocketfuel.cpp, which includes fuel.h, and call.cpp, which also includes fuel.h. When we compile these two files, we will have to parse the fuel.h contents twice, even though its content might be exactly the same in both files, in both cases. Although it doesn't have to be, necessarily. So we can use precompiled headers, which is the first idea. Precompiled header is basically a dump of an AST from the compiler. So the compiler can take the header file and store its preprocessed form on the drive, so that it could be later on reused and prepended to multiple translation units that that don't have to parse it anymore. So in short, we could make a fuel.h a preprocessed header, and it would have to be parsed only once. Although there are also issues with it, depending on the vendor. For instance, there has been recently there was a rather popular blog post on subreddit on CPP about Clang's implementation of precompiled headers, and it turns out that in Clang, when the precompiled header is made, the implicit template instantiations are not. The templates in precompiled header are instantiated implicitly in each translation unit that would use the precompiled header. So that would mean that your build times could actually turn out to they could be way worse with it. Although it's not the case with MSVC, as far as I know. I mean, they store the implicit instantiation in precompiled header already. And I don't want to bash Clang here because there is a patch already for it, which will improve the it will allow for the implicit instantiation in the header file, in the precompiled header file. Sorry. Another idea: single translation unit. So, is there a person in the room who doesn't know what include guard is? Can't see any? Okay. So the include guard is basically a trick with the preprocessor, thanks to which if you include the same header file twice, the second inclusion will not happen. And it's helpful because otherwise you might get a multiple definition error with classes, for instance. But it also means that, the basic idea behind it is that you cannot include the same header files. So now, if we took rocketfuel.cpp and call.cpp and compile them in a single run, so we could create an additional file called translation unit 1, for instance, and include it there. Include both rocketfuel.cpp and call.cpp. Then the contents of fuel.h would be stored in this. They would appear just once in the contents of this translation unit. So that would mean, in turn, that you would have to parse fuel.h just once. And it can be applied to whole code bases, basically, although we have to also be wary of the parallelization, sorry. And there are also more inlining opportunities because now your translation units they have more definitions to work with. So it's almost a win-win situation, except for the cases where you have some static functions, for instance, which happen to clash in names. So for instance, if you have two source files which are perfectly fine on their own, but they contain the same static symbols, or rather internal symbols, in single translation unit, you might get a linker error. And it's kind of, it's counterintuitive in my opinion, but I don't want to discourage you from using it. It's just, it's hard to implement, to do correctly at times. And the third grip of mine is thinking about the way you structure your header files. And it can seem pretty trivial here, but I would actually argue that it's also worth doing. So suppose you have a function that's called doStuff, because naming is hard, and it takes some superclass by reference. And you also have the definition for this function, which returns the member, for instance. But now, what if a.h, so the header file, is not, its contents are very, they could be disjoint at times. As in, what if I could have a reason to include the a.h header that's not related to the stuff? Well then, since there is an include directive for some superclass definition, the person who includes your header will have to pay for it, even though they are not interested in do stuff and its signature. So what you could do here is to forward declare the some superclass class, because you take things by reference, so the compiler can infer the size of the address that it has to pass. And then you could include the actual definition to return the member in implementation file. Kind of simple, but hey, simple things can make big difference. So, and if you're wondering whether it would be hard to do in your code base, there are tools for that. There is an include what you use for Clang, which will go through your code base and check whether there are any opportunities for forward declarations like that. And now the final part is tooling, and this one is not really, well, it's not related to code per se, but we have 10 minutes left, so let's go. The first one is a trivial argument: parallelize your build if you don't do it already. And this is the local parallelism, so you're just compiling with several compiler instances. And I have nothing to say really about it, except for the fact that there was a question about modules, and that's where it kind of gets relevant. It's this is supported by, as far as I know, by Visual Studio and Make, and probably other vendors or other build tools as well. So why not use it if you have spare computing power? Build distribution is a different beast, though, because if you want to compile your project on several machines, you need to be wary of setting up the correct environment, so that if you have the include file, header files from your compiler vendor, for instance, they all have to be the same version, because otherwise your OBGs might not be totally compatible. And well, there are projects for it. I mean, the most popular one is probably DistCC, which has come a long way, I guess. But once again, I recommend that you do your research, basically, if you need it. There were few hands with hour-long builds, and there could be, well, it could be useful here, although the measurement is the first step. So now, caching the artifacts. So most build systems nowadays don't trigger a full rebuild on each compilation. As in, if you only change one source file, there is no need to recompile all the OBGs. And so Make does it, Visual Studio does it, but they do it to, in my opinion, a weak extent. Or rather, I don't want to bash anyone here once again, but back when I started working at my company, my colleague Krzysztof, who's probably somewhere in the audience, hopefully, has told me to never use the build solution in Visual Studio, which is basically this incremental build, sort of, because it's buggy. It's simple as that. It's easier for us to use rebuild solution, which takes 20 seconds, than to test our luck with rebuilding, because it might sometimes give a linker error and whatnot. And with caching, what you can do actually is to have the intermediate layer between you and your compiler. And so instead of checking whether you need to rebuild something, you could always try to rebuild, but check the cache in between. So as a key, you could have the contents of your file, or a hash of them, and the environment stuff like the command line, the compiler version, and so on. And then, sure, your full rebuild will be a bit longer, because then you would have to constantly query the cache. But overall, it's a safer approach, in my opinion, than relying on the rebuild from your vendor, or rather from your build tool. And then incremental linking, which is, for a good reason, highlighted with a different color. Because, well, I actually I did not bring it up, but as the principle for all of these optimizations, I took up having little to none runtime performance. And incremental linking, it's based on the premise that even if, well, none of your OBJ files change, the linker would have to do the same work over and over again anyways, as in it has to relink all the OBJs each time. So with incremental linking, there is some padding added so that the linker could patch up the binary. But that means that you get a bigger binary size and also potentially worse runtime performance. But it could be useful in your scenario, as in for debug builds, for instance. Why not, right? But overall, I don't really use it that much, so your mileage may vary, of course. Now, modules, they were already covered, but just to reiterate on them, no experience, hard to comment on them. It's hard to give a strong opinion on them, but there were some concerns about modules being actually slower to build for very parallelized scenarios, because with modules, the module interface unit, which is maybe it's not a perfect replacement for a header, but it's sort of close to a header file to simplify things, is compiled just once, or rather it can be not even compiled, it can be processed just once. And that means that if you import some module, it might mean that that there would have to be some locking in place. Although, it's only my speculation. And once again, no real experience, so let's just wait and see, right? It might turn out that they're pretty good for you. And lastly, thanks to these people for helping create this presentation in one way or the other, and that's it from me. If you have any questions, then feel free to ask them.